Dr. Pat Mokhtarian has been working in this field for 43 years, really, really distinguished. And we're delighted to have a whole hour with her this morning here in Texas, but a lot of you are at night. I think Giancarlo's in the middle of the night there in Japan. And, you know, we look forward to sharing these slides with thousands of people shortly. So Pat, feel free to take over. Of course, after Pat's presentation, she's taken over the screen. So Kentaro may let go of the screen just to make sure it's easy for her to grab that. But after this presentation, we go into 4 more hours of sessions. So approximately 8 or 9 more speakers. So you can just stay in here all day with us.
Great. Okay. Everybody can hear me, I hope. And yep. I'm still, my face might still be there. That'd be good if I can.
Oh, don't worry about your face. You just go into show mode and we'll be able to see it.
All right. Well, I'm trying to get into slideshow mode. Okay, there we go. But it seems like the face, this is blocking, right?
The speaker doesn't get to see herself, but you look great.
Yeah. Okay. I'm just trying not to block the slides. So great. I think that's good enough. Stop me if it's not. Thank you so much, everyone. Thank you for the organizers for, first of all that hard work, because, yeah, I can't imagine putting on a massive conference like this, but what a gift to the profession. So thanks to every single one of you. And thank you for the invitation to speak, which really is a great honor and a joy and a pleasure. But the honor for this talk really goes to my brand new PhD, Dr. Zhenyi Wang, who is really the first author on this presentation, because this is straight out of her dissertation. So it's been fantastic work, and I'll only obviously be presenting a part of it today, but I highly encourage you to read anything she writes. So we got started on this adventure, if you will, I don't know, 2 or 3 years ago by kind of looking at the literature on teleworking, which of course has been prompted by the pandemic, and all kinds of teleworking gotten underway by necessity during that period. But when we looked at the literature, we realized travel diaries have been used in a couple of different ways to study the transportation impacts of teleworking in the past. So both of these types of studies involve travel diaries, but on the one hand, we have teleworking program evaluations, and on the other hand, general household travel surveys. So let me compare and contrast these two types of studies of teleworking impacts on travel. The telework program evaluations were last century, and I was involved in several of these, but not the only one by any means. Whereas these teleworking questions tended not to appear on general household travel surveys until this century. So we had a spate of studies happening in the last 2 decades. And, the evaluation studies tended to be relatively small samples, not particularly representative, and focused on evaluating teleworking. So you might say that could incur a bias in the results. Maybe the participants wanted to show how great teleworking is at reducing travel, so maybe that biased their responses. Whereas, a benefit of these more recent studies on general household travel surveys were that there was no particular emphasis on teleworking, and the samples were larger, more representative of the geography in which they were taken. But on the other hand, a benefit of these program evaluation studies is that they were panel data. So we had measurements before teleworking, measurements after teleworking, whereas with the general travel surveys, it's by and large cross-sectional. And we're simply comparing people who telework with people who don't telework. And as we'll see, that might give us a bit of a misleading picture. What's really interesting is that the results from those two kinds of studies are almost diametrically opposite in pretty much every single case. That is, the telework program evaluations, panel data before and after, found that, after beginning to telework, travel declined. Whereas the general travel survey studies found that teleworkers travel more than non-teleworkers. And some, explicitly concluded from that, teleworking is actually increasing travel. Therefore, we've got a complementary effect between telework and travel rather than a substitution effect, as we saw over here. Now, I also want to highlight this much newer panel study that has that I just discovered, and it's really a robust methodology, which I highly recommend to your attention, and found, guess what, also that on net, teleworking decreased travel. So let's move on and try to understand why there is this difference between the results that we see from these two different kinds of studies. Well, we had a suspicion, and that is that teleworkers differed from non-teleworkers, even if they looked similar on a number of characteristics that we could observe, but that they are different in ways that we don't observe in such a way that caused them to travel more. So a bit opposite from Kara's initial hypothesis there, because again, we're trying to explain why we see teleworkers traveling more than non-teleworkers in a cross-sectional setting. So what could be making them to travel more even before they started to telework? Well, maybe they're in more autonomous occupations, or their job involves more work-related travel on average. Maybe personality-wise, they have a more active non-work lifestyle, so they're just less sedentary than observationally equivalent non-teleworkers, more risk-taking, adventure-seeking, etc. And if those kinds of things are the case, then teleworking might reduce their travel from way higher than average to just a little higher than average or somewhat above average. In which case, if all you have are cross-sectional data, it's going to appear, all you'll be able to deduce is that teleworkers travel more than non-teleworkers, and you might draw the conclusion that there's complementarity between teleworking and travel. So let me illustrate all those words with a schematic, which is probably worth 1,000 words here. We have on the horizontal axis time, and we're only going to think about sort of 2 periods before teleworking and after teleworking. The vertical axis is some travel outcome measure. We'll be focusing on vehicle miles driven in this study. So imagine, vehicle travel on the vertical axis. And suppose we have 2 groups, teleworkers in purple and non-teleworkers in orange. And if all we have is cross-sectional data, we're observing both groups simultaneously at one point in time after the teleworkers have adopted teleworking sometime in the past. And so all we can do to get an estimate of the impact is compare the travel behavior of teleworkers with non-teleworkers, and conclude that, well, teleworkers travel more, therefore, teleworking appears to have increased travel. But of course, what we'd really like to have is longitudinal data, right? So suppose we could observe teleworkers before they started teleworking and non-teleworkers at the same time. And then what we would see is that, teleworking, once they adopted teleworking, those teleworkers reduced their travel. And so our longitudinal estimate of the impact of teleworking, when we compare these two numbers, is going to be a reduction rather than the increase when we're comparing these two numbers. So that suggests to us that with cross-sectional data, what we need is this missing counterfactual, if you will. That is, what would teleworkers have done or do if they weren't teleworking? And the beauty of the approach that we'll be talking about is precisely that it enables us to estimate this missing counterfactual. And actually, we could have counterfactuals for running all over the place, as you'll see shortly. So that's the idea here. And we have such a model, thanks to the Nobel Prize-winning economist, James Heckman. We have a model called the endogenous switching regression model, which we'll henceforth abbreviate ESRM. And it's designed precisely to deal with this sort of selection bias issue. That is, a situation in which unobserved factors that influence teleworking adoption might also influence how much a person drives. And again, we've just looked at some reasons why that might be the case. And while you're refreshing your memory on that, I want to come back to this expression and say, if you're familiar with modeling, you're probably thinking, ooh, unobserved factors, that sounds like an error term. So an error term in a model of teleworking adoption might be correlated with an error term in a model predicting how much a person drives. So this idea of correlated error terms is going to be crucial to understanding this endogenous switching regression approach. So as we'll see in more detail in a moment, when we have such correlation of these error terms, then if you do a conventional regression approach, that is, why not just take teleworkers, estimate a model of their vehicle miles driven, take non-teleworkers, estimate a model of their vehicle miles driven, and compare the results. Well, the trouble is that those individual models, if you don't do anything to deal with these correlated errors, will yield biased parameters. And again, I think you'll see explicitly why in a moment. So all of this applies when we've got cross-sectional data, and the problem with that data is that we only observe people in one state or another. We don't observe people in each of the teleworking and non-teleworking states over time. We only see them in one or the other of those states at that one point in time. And if we want to obtain an unbiased estimate of the treatment effect, if you will, where treatment in this case is teleworking, on the outcome of interest, and I didn't have space to spell out vehicle miles driven, but VMD will be the acronym throughout the talk for vehicle miles driven, then we're going to need an approach that will again address this selection bias. So let's then get into a little bit of technical detail. These are going to be the key components of an endogenous switching regression model. And I'm going to start with the classic binary case, meaning only two outcomes for the selection, in our case, teleworking or not teleworking. And later on, we'll get to details with more than two possibilities for the selection. But just to kind of keep it simple at the beginning, we've got, first of all, a selection model, which will typically be binary probit. So we can assume that the epsilon, the error term, is normally distributed. And we basically have the sort of conventional latent continuous construct, which is an index function for the propensity to adopt teleworking. And we observe that someone teleworks if this latent index function is greater than 0. And we observe that they don't telework if the function is less than or equal to 0. The W are explanatory variables for adopting teleworking. The gammas are the coefficients of those variables, and you've already seen us talk about the error term. Then besides the selection model, we have these two outcome models, and for our purposes, they'll be linear regression models. And again, we're modeling vehicle miles driven, but to make its distribution a bit closer to normal, we're going to take a log transform, and we're going to add 1 to VMD to avoid taking log of 0. So this is a fairly typical logarithmic transformation of miles traveled type variables. So we're going to have two different outcome models, one if the person is teleworking, and then a different one if the person is not teleworking. So we'll have, this person has whatever explanatory variables they have. Those don't differ depending on, what state they're in. But the coefficients can differ across the two different states. And then we'll have separate error terms for each of these outcome models. And then we're going to make an assumption that all three of these error terms are normally distributed. And so together they are trivariate normal. So this is the vector of error terms, and this is the vector of means. So we're assuming that all three of these error terms have 0 mean. And then the variance covariance matrix. And what's critical here are these terms in the off diagonals connecting our telework adoption model to our outcome models. Rho is the correlation of the error term in the telework adoption model, the selection model, with the error term in the outcome model. So we've got a rho 1 for the teleworkers and a rho 0 for the non-teleworkers. And that's the correlation. So this is the covariance, if you will, of those two error terms. So that's what's critical. And if either of these rows is not 0, then we'll have the selection bias that I've been talking about. And again, you'll see explicitly why later. And if they are 0, by the way, if both of these are 0, then we really don't need to do anything special. We could estimate just individual models for each of these two groups and be perfectly fine. And so I want to illustrate this with a graphic that a previous PhD student, Sung-Hoo Kim, who's now a professor at Hanyang University in South Korea, he prepared this graphic that I think really illustrates nicely what's going on. And before I turn to it, I want to stress that we're assuming, that these ETAs have zero mean over the entire population. But the trick is that we're not observing people from the entire population. When we're making draws, if you will, from the distribution of eta 1, we're only drawing from a part of that distribution, the truncation of that distribution, because we're only drawing from the people who have adopted teleworking. So we're only drawing from the people for whom epsilon technically is greater than minus W gamma. So if, to get Z star greater than 0, epsilon has to be greater than minus W gamma. So we're only drawing from that part of the distribution of epsilon. And if they're correlated, that's a problem. So let's see how this works. First of all, let's assume the simpler case that this correlation is in fact 0. So we've got the distribution of our two error terms. And, technically this should be epsilon greater than negative W gamma, as I just mentioned, but the principle is just the same. So for simplicity, we're just talking about epsilon being greater than 0 here or less than 0. So this is the horizontal axis gives us distribution of epsilon. So this is a simulation, but the empirical distribution, if you will, of these simulated points for the distribution of epsilon is the pink one. And you can see it's roughly normal because that's the way they were simulated, generated by simulation, the mean of 0. And on the vertical axis, we have the distribution of eta 1, the error term for the first outcome equation. And because these are 0 correlation in this case, we have this nice round, scatter plot of points from, draws from each of those two distributions. But notice then that, again, what we're doing with our selection bias is that for the teleworkers, we're only drawing from this half of that distribution over here. We're only drawing an eta 1, an observation on the error term of the outcome model, if epsilon is greater than, again, for simplicity, we'll say greater than 0 here. So we're only drawing from this half of that, scatter plot. And over here would have an identical looking scatter plot for eta 0. And again, we're only drawing from half of it. In this case, the half for which epsilon is less than or equal to 0, the other half from what we're drawing from over here. So since we're truncating that distribution, obviously you can imagine that the mean of epsilon, is going to shift to the right in this case, to the left in this case, because the center of mass, if you will, of this distribution will shift when we're cutting half of it off. But notice what happens to the mean of eta 1 doesn't change. It's still 0. That's because the correlations are 0, right? So again, because we have this nice circular shape, it's just as likely to fall on this side of 0 for eta 1 as this side. And so, the mean doesn't change. But if we do have a correlation between epsilon and eta 1, then our cloud of points has a cigar shape and a slant to it, right? And so this is what it's like in the population as a whole. And then when we truncate that distribution, notice that not only does our mean of epsilon shift, now our mean of eta 1 also shifts. So the conditional expectation of eta 1 given that epsilon is greater than 0 is going to shift upward in this case because we've got the positive correlation. So since when we draw from this half of the eta distribution, we're getting the higher on average points. And because it's correlated with eta 1, we're getting higher than average points for eta 1. So the mean shifts upward. And similarly over here, we're drawing from the lower part of the epsilon distribution. And so because they're positively correlated, the mean for eta 0 will tend to be lower as well. So hopefully you can see that the whole problem comes with this correlation of these error terms between the selection model and the outcome models. And that's truncating the distribution of the expected value of eta 1, and that's an eta 0. And those are what we are actually caring about because that's the regression model, the outcome models of interest. And if we're assuming that eta 1 has a mean 0, but what we're actually looking at is a conditional expectation that's not 0, then you can imagine that we might be in trouble. So let's see then what we have. First is a kind of recap of what we've been talking about, and then I'll show you explicitly this bias term. So we've got the telework adoption question, if you will. Is Z star greater than 0? If so, then we'll have the treated case. And now I'm introducing an observed indicator variable. So Z we observe, and it's equal to 1 if the person telecommutes and 0 otherwise. And then we have the outcome equations, so separate outcome equations for non-teleworkers and for teleworkers, and we're defining Y0 and Y1 to be the left-hand side or the outcome of interest here. And then we've got the correlations as mentioned, and this distribution, which you've already seen. So what's new now is that I want to show you 4 equations. We need these 4 equations because what we're looking for is, the expected vehicle miles driven for teleworkers. That's what this will give us. But what we can only get is the conditional expectation of vehicle miles driven for teleworkers, given that you're a teleworker. So now notice also I've added little subscripts to the X's to denote these are X variables for teleworkers. So they correspond to the Z equals 1. And then these teleworkers will be governed by the teleworker betas. But here's our expected conditional expectation of the error term. And so, as I mentioned before, that's not going to be 0 if rho is not 0. And so without going into the details of why it's this particular thing, this is the bias in the expected value of the error term because of drawing only from a truncated distribution. And I hope you can imagine then that if we ignore this term and just estimate, x beta 1, x1 beta 1 plus eta 1 without dealing with this term, then this term's got to go somewhere and it'll be absorbed into our estimates of the betas. And so that's why I talk about biasing these coefficients if you don't properly account for the fact that the conditional expectation of the error term is not equal to 0. So similarly, we have such an equation for the non-teleworkers. All these are 0 subscripts now, 0, 0, 0 all the way. And here's our bias term for them. But we also then want to look at counterfactuals. And what do we mean by that? So the first one is the counterfactual for teleworkers. And by that, we mean what would a teleworker's VMD look like if they weren't teleworking? So you can interpret that in 2 different ways, either what was their VMD before they started teleworking, or given that they're teleworking now, if they stopped teleworking, what would their VMD look like? So you can see we're trying to look at the expected value of the non-telework circumstance or state VMD, but given that we're observing the person to be a teleworker, so that's their the current state in which we observe them. But what makes it counterfactual is what would such a person do if they were not teleworking? I'm still subscripting 1 because they still have their X characteristics. Whoever, we are who we are, whether we're teleworking or not. It didn't change who we are. But we're governed by the coefficients of the non-teleworker model, and we have the bias term of the non-teleworker model. So that's the counterfactual for what if teleworkers did not telework, and similarly, we have a counterfactual for non-teleworkers if they were to telework. And so I won't dwell on term by term as I've been doing, just to keep things moving. But hopefully you see the basic idea. We have factual equations, and then we have counterfactual equations that allow us to estimate what would happen if the person we observe in one state were actually to be in the opposite state. Now, until now, I focused on the classic binary case here. And again, that's what Heckman and many others started with, where there are only 2 possibilities for the selection, either treated or untreated. But you can easily imagine we could have more than 2. And in particular, when we're talking about teleworking, we wanted to look at least 3, and we stopped at 3 so far, but we could have 3 selection states, if you will, or cases. Untreated is pretty much clear cut for 0 teleworking. But let's have 2 different frequency categories. And we had a suspicion that the less frequent teleworkers would be different in many ways than those who telework almost all the time. So we defined these 2 groups. I'll put their definitions up here in a minute, but for now, just say we've got more than 2 groups here. And so in our case, these are ordinal. So we could treat them either as ordinal or as multinomial. In some situations, they'd be purely multinomial without an ordinal relationship between them, like these could be modes or some other, residential location types or something like that. But then we also can have assumptions on the error term. The distribution of the error term of the selection model could be either normal or, believe it or not, gumbel. And so that gives us this typology, if you will, of a number of different variants on the binary probit model that we were just talking about. And in particular, we'll be focusing on the ordinal probit switching regression model, in which, as I've mentioned, we have 3 states to look at. Not teleworking means not at all, 0. Non-usual teleworking means doing it less than 3 times a week. And usual teleworking means doing it 3 or more times a week. So there are technical reasons for why we defined it that way, but in the interest of time, I'll just go on. And then we also, so a chapter in Ginny's dissertation and a paper that we just submitted to TRB looks at assuming a gumbel distribution on the selection model, and that allows us to do a multinomial logit switching regression instead of multinomial probit, which gets a little technical for a number of reasons, although we're interested in going back to look at that one later as well. But I won't get into the details on this one below, but again, it's a chapter in her dissertation and a paper that will hopefully soon also be submitted to a journal. So I think we'll be switching now to the ordinal probit situation. Oh, but before that, again, another part of our dissertation was to compare the 3 models that you see there in the headline, the binary probit, ordinal probit, and multinomial logit. I'm just going to show you these very quickly and not get into them. We compared those 3 kinds of models on these 4 dimensions, if you will, or characteristics. Again, I've got a bunch of details in hidden slides, but time really doesn't permit that. And then we have some analysis of which ones are better. And long story short, we don't really recommend using a binary probit model. And then after the fact, subdividing the teleworkers into the 2 usual and non-usual categories. It did not work well. We tried it. But then if you look at between ordinal probit and multinomial logit, which one is better for multiple categories, we ended up voting for the ordinal probit in our case. But if you have a nominal selection variable such as mode choice, then ordinal doesn't really work conceptually, so you may have to resort to that. It just has more stringent assumptions, and in our case, our models weren't really following those assumptions very well, and that caused some problems in our results. So we like the ordinal probit model for this particular application, at least. So let's get slowly over to some empirical work and back to our initial question about, what impact will teleworking have on travel? Here's a table of possible impacts. Now, some of these are COVID-induced, pandemic-induced, may be more or less related to working from home, and they may or may not be equally impactful. There's going to be local variations, but you can easily see you're going to have some factors that reduce both vehicle miles, vehicle trips. You might have residential relocation that increases miles, but not trips. Vehicle ownership could increase, transit could decrease, long distance travel could increase. What's going to happen to non-work travel? Big question. So, we've got counteracting factors here. And so the question is, what's going to happen on net? Considering all these changes, will it reduce the total distance traveled? So the objective of the empirical part of our study is to quantify and compare the impact of teleworking on weekly vehicle miles driven. And we confess this is self-reported, so we didn't have the luxury of following people around and getting GPS traces or even doing a regular conventional travel diary. So certainly there's some noise in the self-reports that we have. But the results are quite reasonable, and for what we have, it's the best we had. And so other measures also have their issues as well. So I wouldn't say any one of them are perfect. Anyway, what we're also going to do is to compare our results for different types of workers classified in two different ways. One is these frequency categories that we've been talking about, the non-teleworkers, non-usual and usual. That is less frequent and more frequent. But also we will end up looking at their motives for teleworking to some extent, and in particular, whether they are travel stressed or not. So we'll come back to that. And our goal all along has been to calculate unbiased treatment effects of teleworking by accounting for the self-selection biases that we've been talking about. So I just want to briefly show you the equations for the ordinal probit switching regression. Won't go over them at all because, first of all, they look pretty similar to the ones we've seen for the binary case. And secondly, in the interest of time, but now we have capital J groups, so little j can range from 1 to capital J, which for us is 3. We've got the observed indicator variable for the group that they are observed to belong to, and we know that that will equal little j if the continuous latent underlying index variable lies between these two adjacent thresholds, which can be estimated. The equation Z star equals W gamma plus epsilon is defined exactly the way it was before. And now our J has, again, these 3 values, non-teleworker, non-usual, and usual teleworker. And so here's the equation for the probability that we observe either any of those particular 3 groups being chosen or selected. And it's the probability that the Z star lies between those 2 thresholds, which ends up giving us this difference of standard normal cumulative distribution functions. And then we have our outcome models. This time we have 3. And so we've subscripted everything with J's. And all of that's straightforward. And our variance covariance matrix and mean vector for our error terms looks just like it did before, only now we're going up to J instead of 2. So I think all that's hopefully relatively straightforward. And then here are the formulas that we need. And again, we don't have the time to derive them, but we want our factual and our counterfactual formulas, right? Remember what we did for binary case. And so here we're introducing a bit more generic notation that allows us to look at factual and counterfactual together. The basic idea is that we need an equation for the expected outcome, so the expected log VMD plus 1, if somebody moved into or is already in state J prime, so that's the J prime index here, given that they're observed to belong to group J. So given that Z, that observed indicator variable, is equal to J, then what's their expected VMD if they were in or moved to group J prime, right? So these 2 values, if you will, J prime and J, can vary independently of each other. And we've got 3 states. So we've got 3 times 3 of these equations, right? Now here's the formula. So again, we won't get into details of why it's this on the bottom, but you should recognize this as, sure enough, the conditional expectation of the error term of this outcome equation for state J prime, given that we're observing somebody in state J, right? So, and this term here on the left, the right is exactly the selection bias that we need to correct for. So J is the observed group, J prime is factual if J prime equals J, and counterfactual if J prime is not equal to J, right? So this term I've already mentioned, the selection bias due to belonging to group J. And then one little wrinkle about this is we have this log transformation. So we end up having to back transform because we're interested in the impacts on raw VMD, not really log VMD. And so it turns out to be non-trivial to do this back transformation, but Ginny was up to the job. And so here's the equation for that, which again, we won't dwell on for the interest of time. But what I do want to dwell on a little bit are the components of these treatment effects. So we have the same concept as we showed on the previous slide without the messy equations this time, that we're interested in the expected outcome for VMD, given that somebody, if they moved or are already in state J prime, given that they're in state J, belonging to group J. So here's where we're going to do a 3x3 table of those expected values where J and J prime are separately varying. So in the rows of this table, we have the observed status, the 3 categories that we observe people to be in. And in the columns, we have the potential status that they could be in, hypothetically. And so on the diagonals of this table, we have the factual effects, right? So the expected VMD for a non-teleworker, given that they're not teleworking, and similarly for each of these. But as you might guess, on the off-diagonal elements, we have the counterfactuals. So let's just kind of understand what this means. This one, for example, is the expected VMD for a non-teleworker. So given that someone's a non-teleworker, if they were to adopt teleworking for less than 3 days a week, making them a non-usual teleworker. So given that they're a non-teleworker, all of these in this row, or given that we observe them to be non-teleworkers, what would their VMD be if, they were in any of these 3 categories? And similarly for the non-usual teleworkers and usual teleworkers. And then to get treatment effects, these are just the components. To get the actual treatment effects, we need to look at differences between selected pairs of these expected values, right? So for example, the difference between this one, and this one, sorry, too many clicks. The difference between this one and this one is the non-usual teleworking treatment effect on the untreated. Meaning someone starts out observed in the untreated state, they adopt non-usual teleworking, they go from this much VMD on average to this much VMD on average. So the difference between those two is the treatment effect of non-usual teleworking on the untreated. And this one difference between that one and this one is the usual teleworking treatment effect on the untreated. And then this one, these two give us the treatment effects on the telework treated groups. This one for the non-usual telework treated. Where'd my cursor go? Up here. And this is the treatment effect. The difference between these two is the treatment effect on the usual telework treated. So hopefully relatively clear. I know necessarily we're going pretty fast, but those are our 9 components of the treatment effects. And what we'll see next are a couple of slides on our data, and then we'll get to what these 9 values actually look like for our data. So we do have actual data. We collected something like 1,600 cases. The study was funded by Centra, so they were interested in the impact of teleworking induced by COVID on their toll revenues. So they asked us to survey respondents in these 2 regions where they have managed lanes. And the survey looked at telework and work patterns before, during, and after COVID, prospectively after, of course. And for this presentation, we're focusing only on the during COVID measures. So we took the data and collected the data in 2021. So all of these empirical results deal with 2021. We have also now collected data in 2022 and have just finished collecting data in 2023. So over time, we can sort of replicate this approach on newer data, but Ginny had to get started on her dissertation a couple of years ago. You know how that goes. So we also weighted the data very carefully on a whole bunch of demographic and other characteristics, way more variables than I think most people weight their data on. So the empirical results I'll be presented are for the weighted data so that we'll know that they more or less represent the population, at least on these variables that we can control for. And without further ado, let's look at some results then. So this is everybody together. 2 treatments, meaning, non-usual teleworking and usual teleworking, but we also have the 3rd state of not teleworking. Let's see, the horizontal axis is the frequency of teleworking. So we have not teleworking or zero frequency. And we tried to space our markers so that it's proportional to the actual average frequency of teleworking for each of these two states. So for the non-usual teleworkers, on average, they teleworked 0.8 days a week, and the usual teleworkers on average 4.42. So if we had equally spaced these 3 points, it would not have given the proper effect of, what's the slope should be the impact of an additional occasion of teleworking, if you will. So let's see, the gray lines are the non-teleworkers, the orange lines are the teleworkers, and the green lines are the usual teleworkers. So these are the observed states. So the colors here denote the observed categories that we see people being in. And then, as you can see, the big triangles represent the factual averages, average VMDs. And the lighter circles represent the counterfactuals, in this case, where we're comparing it to the non-teleworking alternative. So we're going to focus on the two observed teleworker groups, and notice then that the VMD of the usual teleworkers, of the non-usual teleworkers, so that's the difference between this light orange circle and this big triangle here. The impact of teleworking doesn't do much, right? It means, their VMD barely declines. It wasn't even statistically significant, but, the point estimate is something like they save 9 miles per teleworking occasion. Well, that's not nothing, actually. So, we don't want to consider it zero, but not very much statistically. And they constitute 15% of the sample, so they are the smaller of the two groups of teleworkers. The usual teleworkers in 2021 were almost twice that. And their VMD, comparing this light green circle to the dark green triangle, declined substantially once they adopted usual teleworking. They're saving on average 21 miles per teleworking occasion. And then our non-teleworkers, if they were to adopt teleworking, they would significantly reduce their VMD in either of these two teleworking treatment states, if you will. So all of that's quite nice, I suppose, but we started wondering about the original conceptual rationale of the endogenous switching regression model. Going back to our godfather Heckman, he says the latent index, that's that Z star function of the selection model, has the interpretation of the expected net utility derived from receiving treatment. Individuals participate in a program, that is, they are treated, if their net utility is positive, and do not participate if net utility is negative. And so the idea is that people choose, they select themselves into a treated or untreated state, partially or largely on the basis of their expectation of returns or gains or benefits from being treated or untreated. And when we looked at the classic applications of these kinds of models, it seemed to us that the outcome being modeled was much more straightforwardly linked to the return or benefit of the treatment than potentially we have here with teleworking. With economics, the treatment might be getting a college education, the outcome is wages. That seems pretty natural that in most cases, people might get a college education precisely to increase their expected wages. In ag econ, the treatment might be a new fertilizer, the outcome is crop yield. So why else would you adopt a new fertilizer if not to increase your crop yield by and large? And so it's logical to assume that people choose the treatment if they think it will improve the outcome being modeled. But, is VMD necessarily the return that people want to improve when they decide whether or not to telework? In fact, certainly if you're travel stressed, then you might adopt teleworking precisely to reduce travel. And in that case, VMD is probably a pretty good measure of the teleworking outcome. But, we would all agree that reducing travel isn't the only possible motive to telework. And in fact, in another chapter of Shani's dissertation, we identified 5 different types of groups, if you will, with different dominant motives for teleworking. And so these are the 5 groups shown here. And these are histograms of the frequency, teleworking frequency distributions of these 5 groups of people. And here's the travel dominant group of people. And you can see, the far right bars in each group are the highest frequency teleworking. Well, the travel motivated people are, I'm going to telework more 1 to 2 days a week than anything else, compared to, somebody who's flexibility motivated. They mostly want to telework all the time. Or if they're family motivated, they're heavily into teleworking all the time. So very different teleworking frequency profiles depending on what your motivation for teleworking is. So by choosing a travel-oriented outcome variable, we may be catering rather nicely to people whose motive for teleworking is travel. But if your motive is something else, like, doing it for the family, then you might end up with more or longer non-work trips to, just have the time to serve your family's needs. Or if you're doing it for the flexibility of location, then you might relocate to an area in which you commute less often, but travel longer. So when we're mixing everybody together with a single model, we're masking the heterogeneity residing in that VMD outcome. So to investigate that, we separated the working sample into 2 groups, travel stressed about half and non-travel stressed the other half. Notice right away that sure enough, the travel stressed travel substantially longer per week than the non-travel stressed. So there's already some differences in their travel. How did we measure travel stress, you might ask? Well, it was a factor analysis, and these are the most heavily loading items on the travel stress factor. So things like my commute is stressful and too busy to do many things I'd like to do, and I'd pay extra to reduce the time I spend in daily traveling. We neutral centered the factor scores, which is a long story, but not a long, but a story we don't have time for, and just use the 0 or the neutral point as the split point. So if their factor score was greater than 0, we considered them travel stressed and otherwise not. So here's the same diagram that we just saw for the full sample, now applied separately to the travel stress group and the non-travel stress group. And you can see at a glance, they're quite different. And let me just go to the next slide where you'll see them again, so don't worry. So there they are again, as promised. And we will look just at adopting non-usual teleworking first. So looking at the yellow panel here shows what happens when you go from non-teleworking to non-usual teleworking for all 3 of the groups. And you'll see that at least the teleworker groups significantly reduce their VMD for both for both groups, if you will, when they're travel stressed. But when they're not travel stressed, the reduction for the teleworker groups is very modest for the non-usual teleworkers, and the usual teleworkers actually increase their VMD if they only go from non-teleworking to non-usual teleworking. So how does that work? Well, a little schematic here shows here's your untreated VMD right here. And when you adopt a non-usual teleworking, then some factors indeed might reduce your VMD compared to what it was before. That's your commute trip savings. But other factors might counteract that and more than counteract it to, in fact, increase your VMD overall compared to what it was before adopting teleworking. So the net treatment effect is shown here, and it can be positive for some of these individuals. So turning to looking at the adoption of usual telecommuting, then we see a reduction in VMD for everybody, whether it's stressed, travel stressed or not. So usual teleworking, not too surprisingly, because it so often is going to reduce travel on net, not for everybody, it turns out. But for travel stress individuals in particular, we see that the slope is steeper for this reduction. So again, the per telework occasion amount is higher for the travel stress people than for the non-travel stress people. And I'll just skip that point in the interest of time. Here's a wonderful diagram of the disaggregate treatment effects, just to illustrate this point that for the travel stress people, most people reduce their travel after they start teleworking, whereas these people above the dashed line increase their travel. I won't go into the details because I know we're running out of time. Whereas the non-travel stress people, if you look at the sort of 45-degree line, or the line of equality between before and after adopting non-usual teleworking. You see lots more people above the line, meaning that if they adopt non-usual teleworking, their VMD would actually increase compared to what it is when not teleworking. So I think this visualization is another fantastic way of kind of getting a fine-grained look at what's going on. Too bad we have to rush past it, but here we are at the conclusions. The endogenous switching regression model designed to deal with selection biases in a cross-sectional setting where we only observe people in one state. We call that the factual state, but the beauty of these models is that we can generate estimates for the counterfactual states, so as if people were in other states. And that allows us to estimate treatment effects unbiased with cross-sectional data. And when we do that, then we actually get results that are consistent with what we saw for all those longitudinal studies I showed you at the beginning, namely that teleworking reduces travel on net. And then we very briefly compared those three types of endogenous switching regression models, saw that we didn't really recommend binary probit if you've got more than two categories. We preferred ordinal probit for our analysis since we had ordinal categories, but if your categories are unordered, then you should no doubt adopt something like multinomial logit switching regression or multinomial probit. On the empirical results, we quantified and compared the impact of teleworking and on vehicle miles driven, and we found again that overall teleworking reduced vehicle miles driven, but most for travel stress teleworkers. And actually among the non-travel stress teleworkers, we had a lot more of them increasing their vehicle miles driven after beginning to telework than we saw for the travel stress teleworkers. It does raise the question, what should we do when we suspect a mismatch between the outcome variable that we're interested in and the returns or benefits that the respondent is interested in? Well, assuming that we've got correlated error terms, we still have a selection bias to correct. So we still should use the endogenous switching approach, I believe. I don't know what else to do if we've got significant correlation. So even if there is something of a mismatch, we still need to correct the bias, but being aware of the possibility of a mismatch might help you explain some counterintuitive results. And in our case, helped us divide our sample into, the travel stress and non-travel stress that gave us, more meaningful and nuanced look at the results. And last, there's lots of other applications of this methodology beyond the one I've just presented today. Cara and her students have used it to look at residential self-selection. There's a whole bunch of other things. Maya's wonderful presentation, I saw her slides earlier today, looking at where was it? Oh, I didn't put it here. The satisfaction with trips. So she was pointing out, that many studies have found that satisfaction with travel varies with mode choice. And you need to account perhaps for people's self-selection into the modes that they prefer to use and that will bring them the most satisfaction. So we very often are having the situation of only having cross-sectional data. So we're hoping that this combination of papers will help generate more interest in this approach and applications of it in the future. So that's all. Thank you.
Thank you, Pat. Thank you very much. I did write down a bunch of these questions that came up earlier, and then I put in a bunch of my own that I will not ask you out loud, but I think you'll be staying on with us. So your friend Deborah Salon asked whether the vehicle miles traveled was self-reported in bins, or can you please remind me how you got that?
Yeah, it was self-reported, but as a direct number. And since the 2021 wave, we did do some more validation as part of the survey itself. So we're going to trust our future years numbers a bit more than the 2021 numbers, but we also kind of screened out extreme numbers, and people with excessively long commutes. So, and very careful cleaning in a bunch of other ways. So I think we already filtered out a lot of the frivolous, most of the frivolous respondents, still leaving people who are perfectly legitimate, genuine respondents who simply can't estimate their weekly VMD very well. So there's clearly, again, a lot of noise in this variable. So we'd love to do it with GPS traces or something like that. So
Yeah, and to this end, Guy Rousseau asked about the frequency numbers. So you mentioned that non-usual was about 0.65 times a week, and the usual average about 4.5. But you knew the exact number for a specific week? Is that right?
Yeah, well, we asked people again in frequency bins. So we had 6 frequency bins from never to less than once a month to 1 to 3 times a month, once a week, 2 to 1 or twice a week, 3 or 4 times a week, and 5 or more times a week. So from those, we took the midpoints, converted it to weekly frequencies. So it was 0.8 per week for the non-usual on average, and 4 point something or 4.4 or 5 per week for the usual teleworkers.
Right, great. And then Eric P. was wondering about whether these data and results would apply long term, but I think this data is so fresh that it is giving us about as good a job as we can do long term. But, you know, many of us, of course, are always worried about the sprawl results, given how much space Americans already occupy, 4 times as much as our Japanese counterparts and about 2 times as much as our European counterparts, which explains why we drive about 4 to 2 times as much, depending on who we're being compared to. So that's tough. I will.
Oh, sorry. I'll just say, yeah, over time, I would expect more people to filter from the usual category to the non-usual category. You know, I think, and again, from 2021 for sure, now in 2023 to 2024, you know, we may be getting close to stabilization, but for sure, you know, people have drifted from, you know, doing it 3 or 4 or more days a week to, you know, 2 or 3 days a week to, you know, 1 or 2, whatever. So that'll change, and not necessarily for the better, because it's those non-usual teleworkers who have kind of the ability to travel even more. And the interest apparently in traveling more. So that could, you know, be a factor. So we definitely want to keep an eye on shares of people in each of those 2 categories, whether the coefficients of our models will stay stable, like, you know, the outcome models could conceivably have stable coefficients, but just different shares of people in each group. That remains to be seen. So again, we'll try to update these results with our later data.
Super. Well, feel free to stay in this room. This room's is now going for connected and autonomous vehicle papers. There's 5 of them. And then the other links that Kentaro provided in the chat box for you guys lead to Jason Hawkins' Urban Transportation Planning and Policy session, also with 5 papers. And then there's another one with 6 papers about electric vehicles and this kind of thing. There's some overlap in the topics given what, you know, was submitted. And then, of course, 2 hours from now, there'll be 4 tracks simultaneously. So, Pat, thank you for you know, kicking off this day and being with us. And your slides will be shared with thousands of people through this process shortly, I think. And you know, hopefully all of you will stay on in one of the 3 Zoom rooms that we've got opening up. So do check the program online and stay with us.
Wonderful. And I'm sorry I don't have time to answer everybody's questions, but feel free to email me, and be delighted. And thanks a lot for your attention. Yeah.
Wonderful. Wonderful. Okay. The